Good afternoon. Thank you for coming. Thank you for attending our session today. We've gotten lots of interest and lots of phone calls and emails from individuals in unique companies, students, in regard to CAM and how to associate CAM and woodworking together without the complication that many of the software packages have today. So our goal is to talk to you about the ease of use of some of the tools we would recommend for most woodworking facilities. The major consideration would be that the software that we're going to use today, of course, is Autodesk Inventor. The versions that we'll be speaking about would be versions 22 through 24. We can connect to earlier versions, but some of the software tools that are in the newer versions weren't in the older versions. So I'd like to show the latest. So the Autodesk products, as well as the Woodworking for Inventor products, are the ones that we're addressing for today. I put up on the screen some of the URLs that are focused and directed to finding any of the packages that we're speaking of. Both of them, meaning Inventor and Woodwork for Inventor, have trials, demo sets, so that you can run them for 30 days just to get comfortable, look at what the capabilities are, and so on. And of course, we're always available to assist any of our end users as well as new converts to how to handle and manage this capability. I put on the screen some of that information that you can get a hold of us. Again, my name is Steve Whittam. I represent Whittam Associates, and Whittam Associates has now been supporting Autodesk software since 1984, so it's a long time, and Inventor for the last 20 years. Woodworking for Inventor is a tool set that adds to existing software, existing Inventor software. So it's sitting on top of it. And you'll see today how well it's integrated. So why am I putting my time in and showing it? Well, first of all, normally I'd record this and make it as slick as possible. Today I decided to do it on the cuff and show you capability. So if I make an error or mistake or what have you, you'll see it in real time. I apologize for that, but I think it's more real than PowerPoints. So why consider a different CAM tool? Well, the major reason we've decided to move in this direction is because many of the CAM tools that are integrated, or they say they're integrated with Autodesk software, are meant for metalwork, not woodwork. So what I'm about to show you is all wood related. And why is that important? Well, the goal for a woodworker, I always believe, is to have something that works efficiently and is easy to use. The key is easy to use. It has to have, of course, accuracy, speed, and a one software solution, which means I don't have to go in and out in one program, out of a program, into another, export it, import it. I don't want to do any of that, because any of that causes the possibility of errors. The other nice thing about what I hope to show you today is that I don't need a dedicated CAM programmer. Think about this. If you have a dedicated CAM programmer and that's all they do, okay, you are spending excessive amount of time to getting work done. What if the engineering department themselves can generate this information for you? And then, of course, going out to the shop floor, and all that's necessary is the CAM operator on the shop floor feeds the machine itself and it processes it. That's what I'm thinking of. That's what I want. I want something that's easy to use, whether I am a large manufacturer or someone in a home shop. I don't need a learning curve that takes forever. The other thing is I want a perpetual license. I don't want to have to keep paying for it every single year. So low cost is something I'm looking for also, because many shops are much smaller than large metal manufacturers, and budgets are very, very tight now. So what if we can have something that's going to give us all these features as well as being inexpensive? And then, of course, being able to machine single parts, left panel, right panel, or kick, whatever, die wall, what have you, as well as nest them. So if I create a job and I want to know how many sheets of 4x8 or 5x10 and what's going to be hardwood and what's going to be softwood, why not have all of that at the same time? Full cut lists and bills of material. Well, all of that is possible. Now, I'm not going to spend hours and hours presenting this. I'm going to show you key points in real world scenarios. And if any of this seems at all to be interesting to you, we're more than welcome you to call and we can go into a deep dive for your particular needs. So let's go into the actual file itself. So what I've done here is I've created a very, very simple unit. Panels, hardwoods. You could see that, I've got the plates on the back, which would be hardwood or softwood. You could see the grain direction, whereas the panels themselves, the top, the bottom, left, and right, are all, this is MDF on maple, or maple on MDF, I should say. So what we're looking at is a real world scenario. Now let me turn off one of the doors. So I'm going to turn the visibility of the door off, and you'll see I have hinges, of course. Shelf pin holes, conformat screws. And again, if I turn off, let's say, the visibility of the top, you can see these true conformat, and there are holes that they're going into because I need to machine, or I would like to machine all of that. The model itself was done in Inventor using Woodwork for Inventor. It is a parametric model. It gives me the ability to change its size, its depth, its width at any time. Today's session is not in building the model. It is after the model is built, what can you do with it? Where do you take it from here? And that's sort of where I'd like to go. So let's put the door back on. Okay. Now, if I open the door up on its own and take a look at it, you could see that I have, of course, all the pilot holes for the hinge. I have a rabbet for the back, for maybe this is going to be a grill work, maybe it's going to be glass, whatever. So it's not just a simple solid body model. There's a lot to it. And again, this is a simple model, but the goal here is to show simple models or more complex models, how easy or how difficult it is to generate. So this model, if I didn't have a library of these and I had to build it from scratch, is probably about 15 minutes worth of work. Fully parametric, so it can change size at any time. But then what do we do about machining it? Okay, so this is where our session really gets started. Okay, ease of use is the key. Cutting out cycle time to the shop. The one thing one has to consider, though, is that engineering now controls the machinery. Okay, if I build something here and go directly out to machining, whatever I build should be machined exactly as I built it. Sounds logical to me. But again, that means tolerances. That means thicknesses and widths. That means materials. That means grain and grain direction. Because obviously the grain direction will make a big difference when one starts. So I'm going to just start with some simple pieces, and then we'll graduate into full nesting, all the parts at one time, and so on, so that you can see this. And again, I definitely would love to hear from you after our session this week, next week, if this seems logical to you, and if this is meaningful enough that you might want to take a look further in your world itself. Because we use this not only on 6 parts, but on 600 parts. So I'm going to get started real simply by I'm going to grab the shelf at this moment and pick open. So I'm on the shelf itself at this particular time. Now, if I wanted to machine this shelf, this is really simple. It's a rectangle, it has no fittings whatsoever. And just to give you an explanation of why I'm doing this is to show you some of the tools. At the top of the screen, you'll see that we have our woodworking tools. Okay, integrated perfectly inside of Inventor. I don't ever leave Inventor. I never exit out. I never open something else up. I'm always in Inventor. If I now went ahead and said I want to automatically machine this, I pick auto. I pick one of our posts, and the system comes with about 15 or 18 posts. They're not extra. You're not paying anything extra for them. So if you're using a BSE, or you're using a HOMAG, or you're using an Ansroot, I mean, we have posts for them. If you have something very unique, then of course we can write the post or automate this so that it can be handled those also. So I'm going to use a BSE post for the moment, and I'm not nesting at the moment, so I'm not going to click on nesting, and I pick OK. I'm now done. That's it. The end. Done. If I went ahead and I say I want to look at it, look at what I just did, look at the information associated with what I just did, I can say enter the CAM environment. And over here on the left-hand side of the page, in the browser that people are familiar with already, you'll see that this is the post. It's already clamped it automatically, and it's labeled the top, the front, the back. It labeled all the sides. And because there's only one operation, which was the milling around the outside, it listed a milling operation, and I had it defaulted to a 3/4 inch bit. Doesn't have to be. And underneath that, you could see that it's telling you what the spindle numbers are, whether it's clockwise or counterclockwise. And of course, geometry goes further. It's telling you the thickness of the pieces and so on. If I do a simulation of it, and I run the simulation, you could see that it's now processing that, and it's now done. Okay, that's it, the end. If I want to output it to a file that the router can see, I pick output. It asks me where do I want to place it, because it could be on the network, and I can say generate. Do I want to open it? Sure, I'll open it to show you that this is the post. It's already done based on a BSE equipment. So that's how simple that was. Now, let's go further with this. If I said I wanted to change the grain on this, I pick grain. Let's take a look at it from the top. And let's say I want to change the grain to 60 degrees, 60 degrees, 60 degrees, and pick apply. It's now grain at 60 degrees. Okay, so I visually see this. That's kind of neat about this. Now, when we look at something like this and we need to machine it at a 60-degree angle, well, the size of this has to be a little bit different. So we can always go into our bill of materials, and we can see this is the name, it's a bottom panel, and the actual size, if I went out and measured it in the shop, would be 45 7/8 by 10 inches, and it's 3/4 of an inch thick. But because it's on a 60-degree angle, it already tells you need a board that's 32 by 45 to be able to manage that. So you're seeing that there's two dimensions already. The actual final dimension that you measure, after it's assembled, as well as the work piece, the work dimension. So what does that mean? Well, If I now picked auto and I went to simulate it, it's a little different. Notice it's cutting it on a 60-degree angle. And again, because it's MDF, it's maple on MDF, it is showing you that with or without the veneer, this is what would happen and the grain would actually show correctly. So just really simple things like this are done automatically. And it's more towards what a user would consider to begin with. Now, that's fine one at a time, but I don't want to do one at a time. I want the expediency of the tool. It's a computer. Let the computer do my work. So what do? We're in the assembly now. And we say, I would like to automatically machine it, auto. Notice it picked up every single part. I'll do that again. These are absolutely blank. I pick auto, and it will automatically find all the pieces that can be machined, which is what it just did. The hardware itself, it's not going to find. Let me show you that. I put the hardware in a separate folder. They don't have to be in the separate folder at the moment. But if I pick auto, it does not find any of the hardware. Why? You're not machining hardware. You're machining wood or plastics, or this could be glass. You know, you can do things like that too. Not that you can machine it, but at least you can process it to a blank of glass. Okay, so I found what it had to do and I pick OK. So now it's working through all the parts, which is what it's doing at this moment. So whether there's 6 parts or 600 parts, you know, the process of your computer makes a difference now. Now I'm on a 5-year-old laptop, so a little slower than I would want, but it still does a great job. So what are we doing now? Let's just take a look at this. Each of these parts have already been machined. They already have the code on it. Now, if I picked, for example, what is called status, I want to know the status of this information. I pick status first. And you'll see once you do that, there's a little check mark on all the parts that have been machined. And what hasn't been machined has an X on it. And there's reasons for why these stretchers have not been machined, because they might be pushed through a table saw. There's not much going on. I don't need to machine it. So I have a tool that says if you're a straight rectangular piece as a single part, maybe with an angle on it, it's going to go through a table saw, it's going to go through a panel saw, or whatever. So you can now segregate things that go to a panel saw as well as things that can go to a router. Now, once that's done, okay, let's take the door, for example, and I'm going to just click on it, and this automatically puts it into the machine mode. As you can see here, I'm in here. Let's rotate it around. And it automatically added all the machining to this, because if I now go ahead and say, let's take a look at the browser and look at the top, that's where it's machined from the top. I pick the plus sign, and you see here are the operations. It's done blind drilling for the large cups. Now, that could either be a drill or it could be a mill. It's up to me to make that decision. Do I have an 1 3/8 milling tool, or I shouldn't say a drilling tool, or I don't, and then it would mill it instead. You can see it's doing blind drilling. It's doing through drilling, because that's where the handles are. It's milling around the outside, it's milling around the inside, and it's pocketing for the rabbet. Okay, let's do a simulation. So it's drilling, it's coming around, and you'll see how many passes. You can define how many passes you want to do. And of course, you know, it's processing it, and it's now done. Okay, it's doing the, of course, the rabbet. And that's done. So again, I don't need someone touching it. I'm the engineer, process the data. And what's also interesting about this, everything that we're doing stays on the files themselves, on the part files. It's not a separate file. It's not something you have to manage. It's not something you have to put somewhere else. It's all here. Everything is here. So that if you are using Vault, it goes into the Vault because it's on the IPT file. It's on the assembly file. It's not a secondary file. Again, helping us so that if we call it up again, we can just process it. We don't have to do anything. We just say, okay, output, and it's done. Let's go ahead, and I'm going to close out of this right now. Okay, so that's now taken care of. Okay, so you're seeing those two are done. Let's take a look at one of the left panels. Okay, so I'm going to say status first, and that just gives me the option of highlighting. You can see I can highlight it, pick it, and then just process it. Yes, I could open it up just like I would in any Inventor file, but that's what's being done. And if I go to simulation of it, you can see it's processing all the holes, the shelf bins, and it's doing horizontal boring also. It already did the horizontal boring. I'll do that again. I'll slow it down a little bit. So it's doing face boring. It's doing horizontal boring. Now it can't do it. You can't nest that way, but on single parts, I can now drill a horizontal or on angles, and it's all automatic. That's what's happening at this point. So doing rabbets, doing dados, doing pockets, doing milling, doing through drilling, doing sawing, because we can saw instead of mill if we want, and it's processing that data. Let me come back out of this. So on something like this, what I would do here fairly simply is this. As I did before, I'll do it again. I pick auto. I process everything here. And then I'm going to output it for the machine. So something that normally would take many of our users, woodworking users that we support, 15, 20 minutes, is now taking us 15 seconds. So all of that's done. And now what I do here is I go into, of course, let's just look at this. We now say output. It's reading everything I've just done. It's going to process it to the CAM directory or wherever I want it to tell it and generate it. Now, because I'm doing 10, 12, 15 parts at a time, it is saying, do you want to open the directory, not the file itself? And I say yes. And here are all the files. These are the individual files that have been created. They are automatically being created utilizing the name of the part, the physical name of the part, and it's using a prefix of J1C1, C1. If it was double-sided machining, which we do also, and we can automatically see that, there would be two programs, C1 and C2. And if I open up any of these, again, it's new code. Now, these could be placed on the network. These could be put in the vault. These could be wherever you want to place them, but they're all unique and individual. And if I was using Woodwop as a, if I was using a HOMAG or a wiki, then of course this would be an MPR file, okay, instead. So the post will determine, of course, the output configuration that would be necessary for your machines to be able to understand what was just done. Okay, so let's do this. That was all done automatically. All of that was done automatically. So you say, Steve, but maybe I don't want to do it automatically. I want to do it differently, okay? Okay, so let's just take a look at that. I'm going to take For example, let's take this side panel and I'm opening it up into its own file. Again, I'm in AutoCAD, of course. I'm in Inventor, I'm sorry. And I want to do something unique here. Okay, so I'm going to sketch on here. I'm going to create a simple rectangle. Again, this is straight Inventor. I'm going to dimension this. Let's make that 7/8 or 3/4. And let's add a dimension between here and here. Let's make that 5 inches. And then I'm going to extrude this down. Let's cut into a 3/8, 0.375. And we'll cut. That's fairly simple. And let's do something a little more unique. I'm going to sketch on this again, and I'm going to create something different. I'm going to offset that, let's say 1 inch. And I'm going to extrude this down 1/2 inch, 0.5. So now as a user, as an engineering person doing design work, okay, that's the difference now. I have now created some unique things here that I want to machine. I figured it out. I decided on where I wanted to put it. I understood something how to fit into it. I didn't have to go to the CAM person whatsoever, because all I now have to do is this. I pick auto and pick OK. Okay, so that change happened that quickly. And if I enter the CAM environment and go into simulation and run it, drilling the holes, side boring, perimeter, and now it's doing the pockets. Engineers, now, good and bad. You're the ones that are responsible for your work. If you design it incorrect or you forget to do something, it doesn't machine it. But you have a true model always of what's going on here, always. Now, again, this model has changed a whole bunch of times already, and you can see what's going on in here. Now, if I were to not do it in an automatic mode, this is all automatic mode, and this is what I like, because it gives me functionality that I don't think many other programs have, then maybe I want to do it more manually. Maybe I want V-cuts. Maybe I do a miter folding. Okay, so maybe I do something with a unique profile. All those things are absolutely possible, but some can't be done automatically and some can be done automatically. This is mostly for panel processing, okay? I'm not doing intricate details of windows with very unique profiles and, strange cuts for weather stripping, what have you. There are other tools that are better for this. This is mostly 2.5 to 3 axis. So if you need 5 axis for some reason, then this might not be the best solution for you. But if you're using any type of panel processing or single parts, then, as I said before, the benefits outweigh, anything else that I believe is in the marketplace today. And our company has been supporting this tool now for over 10 years. So we know where the strengths, we know where the weaknesses of many of the tools that are out there. We have companies that do a lot of knockdown furniture, where they have all types of fasteners, dog bones. They have mini connectors. They have locking dowels. All of that stuff, biscuits, all that stuff is doable. everything that's there, but it's modeled correctly, and it'll be machined correctly. So let's take a look at a single part development. I'm going to open this up. Okay. And right now, if I were to machine it independently, okay, have a single part, I don't want to do it automatically. I want to tell it many of the things that I normally would tell. What I'm going to do is go into Woodwork Design and go into the CAM environment. And it remembers the data that's already on it, of course. That's what everything here. Notice it says the top. Here's all the machining that's done from the top. Here's the machining that's done from the back, from the left side, and from the right side. So it already labeled everything for you in the automatic mode. What I'm going to do is delete all my machining. Say yes. So there's no machining anymore. So this is blank. It doesn't have anything. It won't process. I mean, if I did auto, it'd all come back. But what I'm going to do is go into what is called a job. I'm going to create a job. It asks me what post do I want to use. I pick create a job. And then it's asking me, where do you want to clamp it? Clamp. So you can see on all four corners, you've got these little bubbles. And if I pick one of them, you can see that's where it's going to clamp. Of course, these are the pins that are in the table for most. No, it should have been there. No, it should have been there. But if I pick the bottom, it's for the reverse side, of course. And now it's for the back side. So you pick that. That determines this is the front. Okay, that's what's happening. This is the front. This is the left. This is the right. And if I pick OK, it's now done. Sorry. It's now done. So here you can see top, front, back, left, and right. So that step is done. Now, here are your operations: drilling, milling, pocketing, grooving. Okay, instead of milling, you can cut a groove for a dado, like maybe for a back panel, or cutting on all four sides rather than milling, or cutting on two sides, or cutting on three sides. Angle cutting, anything that you might consider, okay? So what I'm going to do is say drill. So when I pick drill, it finds all the holes, and if I have a drill bit that has been determined in our library, it comes up with this bluish color. Because I said use all spindles. If that is unchecked, everything is red here. That means nothing is selected. And then what I can do is go through the system, and I can say I want everything that is, let's say, vertical through drill, nothing. Oh, there. Those are all vertical blind drills, okay? 0.197, or this could be metric. So it found all of those, and I pick apply. So that's all done. Notice in here, the drilling has been added. If I want to mill something, here is the tool set for milling. First of all, what tool do I want to use? And this will be, you list all your tools. What type of step over? What type of lead in, lead out? Do you want a corner recess? What's the breakthrough? And all you have to do is touch 1, 2, 3, and 4 and pick apply. And close. And now you can see milling is here. So if I did a simulation, you could see that it's drilling the holes, and then it's milling around the outside. But I didn't tell it the depth of each pass, which I could do, of course. Okay, so let's take this just one more step. Sometimes you have in your system a kick, an inside corner. So I'm going to sketch on that. I'm going to create a simple rectangle. And I'm going to cut that out. And pick OK. If I now go ahead and I say I want to automatically machine it or manually machine it, I've just taken care of it. Now let's take a look at what was just done. So you could see here is your milling, and I'm going to run the simulation. And the order in which it drills first or mills first, of course, is completely up to me. Did a good job. But I don't like that inside corner. Sometimes some of our accounts drill first, create some sort of relief here, and they have to play games. Not in our world. In our world, we can go to the milling tool here. All the information associated with the milling tool is here. Everything that has to do with the geometry is here. And of course, I can suppress this or unsuppress this. And there's something called corner recess. And I'm going to turn the corner recess on. The corner recess is on. So now when I do a simulation, interesting. I don't have to add anything extra. I don't have to put anything in my model. It'll do it automatically, and I can control that. Now, that's the same thing when I created when I did the milling to begin with. You could see that there is something called corner recess. I can turn it on or off. I can tell it what the corner recess should be. So, and the step over, each cut as it's actually going around the part. All these things are controllable, but what in an automatic mode, I have preset this to the most standard item, but I can always come back in here and manipulate it if I wanted to. Okay, let's go further with this. I'm going to get rid of that extrusion. Let's delete it. Let's close out of it. And I think you realize or could realize that I'm getting so much work done in a minimal amount of time. And if I can save the CAM person's time or the possibility of errors between the two, we have. And as I said before, this is the least expensive tool, I believe, in the marketplace. So again, if someone's interested, they can always talk to us. Okay, let's talk about nesting now. More interesting for some of us. So I'm going to just pick save to save my work. Now, nesting. What is the benefit of nesting? Nesting allows us to take the parts from an assembly and place it on a sheet of material, whether it's a 4x8 or a 5x10 or a 4x4 or a 2x4, and configure it to get the maximum usage of the sheet. Good reason. If you have a nesting router, okay? The other benefit is to know what your costs are, of course. Know how many sheets you need for the project. All those things are important. Okay, so our tool segregates this in two ways. First, like materials and like thicknesses get nested on the same sheets. So if I have, this is all maple on MDF. Everything here is maple on MDF. So this would all be nested on single sheets. But if the doors were made out of something else, they would be nested on a different sheet. Makes sense? Or if the framework or the carcass had two different thicknesses, they would be on different sheets. So all of these things assist us in, verifying our model also. Yeah, we think everything's 3/4, but then we find out later, later that the interior dimensions of those shelves were not 3/4, they were 19 millimeters. So they're not going to be right. Or the joints are not going to be right. So the way that we first attempt to accomplish the task, again, is in an automatic mode. We pick auto, but instead of just going out to the post, we now say we want to create a nest. That's the only difference right here. And we can say we want an onion skin or not an onion skin. We want bridges. We don't want bridges. And again, when you're nesting and you have a vacuum table, you want to be able to hold those parts down. So I pick OK. And it's doing exactly the same thing that I've done already. It's processing all the data. Again, under 15 seconds. And it's done. Now, I want to nest. So I pick nest. And here it's saying, do you want to nest everything here, or do you want to just select the items you want to nest? Maybe I just want to nest the carcass. Maybe I just want to nest the doors. Maybe I want to nest the doors and also book match them. Maybe. Right now I'm going to nest everything, so I just hit the check mark. And they're nested. Oh, look at this. The bottom panel is on an angle. We'll have to check that out. What you're seeing here is each of the parts. They're all 3/4 of an inch, and they've done the best job they can. But let's look at this bottom piece. I'm going to close out of this. Okay. That's this guy here. So let's change the grain. Reset it. And pick apply. Just reset. And close. And now auto. Grain was in the wrong direction. Maybe it was in the right direction, but you saw it when it nested based on the grain direction. So what you see is what you get. It's not having some symbology that you have to deal with, or someone has to tell someone else what to do. There has to be a note, a tag, a piece of text, whatever. None of that is necessary. Let's nest. There it is. Left panel, right panel. There's my dado. There's my curved dado. Everything is here. You can see. And what you can also do is you can click on this, right mouse, and simulate the nest. So here's the sheet, whether it's a 4x or 5x, that's completely up to me. And I'm going to say run the simulation. So I have the graphic turned off so that it's easy to see. But okay, so now you're seeing the door. You're seeing the pieces. And it's done. That's what you would expect. So if I went ahead and said nest and take a look at it again, those are the two sheets. I'm going to come over to this sheet, right click on it, simulate. This time I'm going to say workpiece translucent. I want to turn that off. Let's take a look at this and go. So it's a little harder to see, but it's machining everything right now. You can see what's going on. It's drilling. And if the grain direction, of course, was what we wanted, okay? If it was different or unique, then of course that would nest correctly. So that's done. The spacing between the parts are fully adjustable. You can have single line cut where the tool does a single pass and machines both sides. It's a little rough. You know, usually most machines don't do the best job. They get some tear outs. But if you want, you can do a double cut or a triple cut. Again, all of that is adjustable based on the equipment that you have. So it's very, very variable. Okay. Now, I'm going to nest it one more time. Nest. Okay, here's the nest. Same material, MDF, maple on MDF, 3/4 of an inch. But wait a second. I have 12 of these I have to create, or 8 of them, or 6, or 60. What am I going to do? Am I going to do this? Let's just look at this for a second. Am I going to come over here, do a Control C, Control V, right? Control V, right? So we put multiples in the job? No, 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 no. That's not going to work. That's not that good. Oh, that's lovely. I'm in a loop, it looks like. Bear with me a second. I told you it's live. There we go. Yep, that's what happens. Let's go back. Let me just launch into. Give me a second. Let me launch into Inventor. And because everything is part of the assembly, meaning, as I said before, is part of the parts and parts of the assemblies, there's no external, file that I'm generating. File open. Just open it up and I'm back where I was. Again, normal save, just straight Inventor. One second. Oh. Okay, that's where we are. Okay. Now, the reason that what was happening is when I outputted why it couldn't find certain things is when we output to the actual router. When I went in here and I said I would like to output the data, notice in the browser it actually placed an external file here pointing to where the output data is. That's what's going on here. I just put it in a different folder. That's why I didn't find it. So you could have this turned on and off so that now you know that the left door or whatever the file name is, this is the post output for the left door. So you can call this up at any time. And this goes into the Vault Basic or Vault Professional automatically. This gets added if you want it. You don't have to have it. Okay. So what I was doing here, let me just pick save, make sure I'm clean. Just saving my work. Anytime the system crashes, I always go back to a save. Okay, we'll go to Nest. Let's go to Auto. Click OK. And then we'll nest it. Okay, and then I want 6 of these units. That's where that's where I was previously. So just the fact of trying to copy and paste and play with Inventor crashed me. Okay. I don't want that. I don't need it. So here, when I nest something, here's the nest, and I didn't save it, so that's on an angle still, right? And if I went to what is called included products, because this is information associated with each of the parts, each of the panels, I should say, you could see that all this information is in the browser, just like everything else in Inventor. I can do included products, and I say, you know, I don't want one, I want 6 of them. That's done. Done. So what you're seeing here is you have one, I now need 6 of them, or 10 of them, or 20 of them. It has now optimized it, and it's on 9 panels. 9 panels. Okay, let's go further with this now. I'm going to take the doors and make them out of a different material. Okay, I'm going to pick a sign. And what I'm using here is, of course, Woodwork for Inventor, the design tools. Okay, so if you don't have Woodworking for Inventor, then, you know, you can't use this. This is, again, a module within that product. So what I want to do is I want a panel, and I'm going to say it's pine. Let's say pine on MDF. So I touch door 1 and door 2 and pick apply. So now that's a totally different material. If I went ahead and said, I want a bill of material, let me see more about this, okay? I can look at the left door, and the left door says it's made out of, it's pine MDF. It's 822 square inches, or this could be square feet if we wanted to, but the top panel is made out of a different material, and that's maple on MDF. So you're getting all this information at the same time. You're getting this information out. So let's now go ahead and process this. Now there's 2 different types of material. We've got pine and we've got maple. Or we have 5 different materials or 10 different materials. It doesn't really make a difference. Let's nest it. Okay, so at the bottom of the screen, notice it says MDF maple, and now it's pine. They're the 2 boards that are pine. Totally segregated. And if you want to book match them, you can just grab it. Now they're book matched. Because if you process it right now and I do a simulation, this is the simulation. You'll see this. Or I can click on this and I say copy and paste. And I can put it over here. And they lock together, as you can see it. You can paste again. You can get as crazy as you want, and you can actually turn this in real time. And I want it up there. So if I right click on this and I say, you know, I want to simulate it, and run it, it's drilling the holes. So you can see here the 2 panels, the 3 panels, and the one on an angle, and that's what it's going to machine. So if you're doing a one of, or you're doing a small series of items that you need to replace something, a broken part, you missed 1 or missed 2, or for whatever reason they were damaged, it's this simple to just come back in here and manipulate it. So you can see it's doing the same thing that it's done previously. Okay, let's go further with this. Let's go back to nesting and let's get some report generation. Oh, one more thing. Let's take one of the doors. Let's take one of the doors. Let's take this shelf and make it thicker. Okay, that's easy to do. So the first thing we're going to do is grain, and I'm going to do a reset so it's not on an angle. The second thing I'm going to do is I'm just going to click on this. I'm going to sketch on it. I'm going to extrude it. And let's give it an eighth of an inch more, 0.125. One second, 0.125. So I added an eighth of an inch to it. That's all I did. So now when I go ahead and I say I would like to automatically machine this to a nest, and nest it. Yes, it's the same material as the carcass, but it's a different thickness. So at the bottom of the screen here, notice you've got MDF maple, you've got pine MDF for the doors, and you've got MDF maple at 7/8 of an inch. So again, it's segregating it completely, and I don't have to consider it. So now, if for some reason it was 15/16, and I go, wait a second, I don't have any 15/16 boards. What's wrong? You go back to the model and change it, manipulate it, edit it, and you're good to go. So this is a checks and balances also on top of everything else. Okay, let's do one more thing here. I'm going to make, let's make 3 of them. Okay, so notice there's 3 boards here. Okay, let's go further. Let's make 9 of them. Okay. If I now wanted to do certain things, for example, if I wanted to put onion skin on this, okay? You could have done it previously, or you can go into apply onion skin, apply. And you could see that I've applied onion skin to every board here. Remove. Or I can do bridges, auto. And if we take a look at this, right, you can see, let me just highlight one of them. Auto. Bridges now become available, and remove them. So again, just real simple things. Now, there's a lot of functions here for reversal. That's what you're seeing. I'm just moving out. So take something like this, you can highlight this, and you can see, you can say flip vertically. Do the bottom, the top, the bottom. In case something is not correct, you have this option. It's labeling everything for you. That's the file name. This is the size. This is being done. Okay. You can add a new sheet. What is the size of the sheet? Pick OK. And then you could right-click copy, right-click paste. As you can see, I threw it up here by mistake. But again, those are things that you can do more independently. No, report generation now. Report generation. If I went to bill of material, I can use multiple templates. These are Excel templates that you can create on your own. I'm going to use one of the templates for reports. I'll say I want to go out to Excel with it. Pick save. Okay. So it's now going in and reading this information. And yes. Okay, so here is the information associated with nesting. You could see that each board, sheet 1, sheet 2, sheet 3, sheet 4, sheet 5, sheet 6, 7, 8, 9, material, the parts that are involved in each of the sheets, the sizes in each of the sheets, the number of sheets, but this is in what is called nesting. If I go to what is called sheet consumption, okay, it is showing you that we have 3 boards, 3 types, 3 different types. You have MD, you have hard maple, 2 different sizes, 3/4 of an inch and 8.75, right? You're seeing that immediately. That's what's going on here. Sorry. Let me move some stuff out of my way. Okay, it's saying how many boards? I have 9 boards that are hard maple that are 3/4 of an inch. I have 3 boards that's pine, that's 3/4 of an inch, and 2 boards that are 0.875. So this is immediately telling us what's going on here. And each of these pieces of information down here is pulling information from a model. And you can see how quickly this is working. So that's one thing we can do immediately. And this is customizable to what your needs are to an extent. I'm going to pick a different template, and I'm going to say I would like to see a nesting sticker book, to what we call it. Go to Excel with it, pick save, and yes. Here, it's going to be a little bit different. Now for labels, for information that has to be done at the shop floor, okay? Okay, it's processing everything here. And here, what you're looking at is the names of each of the parts. That's at the bottom in these tabs. And here is the bottom panel. It shows you the bottom panel here. That's kind of neat. Names it, shows you the drills, and it's also telling you on sheet number 1, this is the location. This is the physical location of this on this board. This part is at this section of this board. It also is pulling information about it. Each of these are controllable. Here's the top panel. If we look at it, let's go further. Bottom, back, bottom, back. You can see as I move my mouse left and right, you can see here's the left door. Okay. Here's the door. That's where one of the pieces are. That's the size. So this can all be printed out. They could be printed to a sticker, a printer, a label printer, if we want. It's configured for that, but it doesn't have to be. This can all go to PDF if we wanted to, because when we say print, the setup for printing, you can print the image, print to Excel, print by picking, print to a PDF, all different types of printing capabilities that you have here. Okay. So what we've done in the last 35 minutes is work through so many of the functions that are part of our Woodworking for Inventor CAM with nesting. And we've seen people that have had very extensive CAM systems. And they do a great job. I'm not questioning them. But when they need to do something quick, fast, easy, and let the engineers do it, they're waiting. We're too backlogged. Here now, we're democratizing the ability to do CAM. And the ease of use, I hope I showed you, allows for this type of interface. And all I could do in this short time, because I didn't want to draw this out to an hour, is give you a sort of an indication of capability. If anybody within the group wants to see the actual on their own assemblies, please just call us, let us know, email me, email my staff, and we'll be happy to do a one-on-one presentation of this tool. We also we really haven't talked about panel saws. We have functionality also for panel saws. Right now, this is a router, whether it's a single part route, a single piece router, vertical router, nesting router, it really doesn't make a difference. If we don't have the post for your machine, let's say you have something very unique, or you have some form of drill head an aggregate head that is somewhat unique, sometimes we're going to need our post team to work with you to develop it. But we've been quite successful, heavily successful with knockdown fittings, because all of those types of drilling and milling operations are necessary for these the fittings that are being used. So I thank everybody for being part of our system. Give me a second and let me bring up our screen so that if you needed to contact us. Oh, sorry, went too fast myself. Yeah, I wanted to show you this. This one was an interesting one. We just finished a project with one of our clients to do an undulated ceiling, okay, where these are changing. Each one of these changes so that it looks more like, a wave. Absolutely nested. Everything is nested. This is MDF with edge banding on it, okay, so that you don't see the material, and then it's just slapped together because it all was nested correctly and maximized the space. So this was one of our good ones that was recent, okay? But again, it's the same thing when we look at traditional furniture, okay? We're not going to do dovetails, okay? So these are dovetail drills. I'm not going to do dovetails, but if we're doing mortise and tenon joints, we definitely can. These are square, so I'm not going to be able to do squares, but there would be more radial based on the diameter of the milling tool. So I just don't want you to feel that it can only be used in one area. Display companies, trade show booths, that stuff is pretty simple. And they're also knockdown. So the fit is very, very important for most of the work that is being done. So again, I want to thank everybody for attending. I hope this was enlightening to some degree, hopefully a little enjoyable. We have many, many other presentations we've done on YouTube. Okay, so this is our, I think, 12th year of doing presentations. We try to do, 6 or 7 a year. And any input that you can give us in terms of areas that you might think need to be addressed, we'll be happy to do that. We are, of course, wood focused. That is our business. And I thank you. And again, my name is Steve Whittam, Whittam Associates, and you can reach me at the email as well as the phone number that I'm presenting on the screen. Again, thank you guys. Have a great weekend. We got another day. It's nice weather here in New York. It's about 70 degrees still, so we got a little more time before it gets cold. You take care.